Today I'll be proving the following identity, trigonometric identity. We've got pi over 4 on the left hand side, and right hand side is 4 times arctan of 1 over 5 minus the arctan of 1 over 239. Okay, and a fun fact, this formula can be used to find pi to a lot of decimal places. This is because arctan 1 over 5 and arctan 1 over 239, there are some fairly easy ways to compute those numbers to a large number of decimal places, and by combining them you can use it to find what pi over 4 is. Okay, so let's get started. First I'll bring over this arctan 1 over 239 to the left hand side. So we can write the left hand side as equal to pi over 4 plus the arctan of 1 over 239, and we can write the right hand side as 4 arctan 1 over 5. Now what I'll do is take the tan of both sides, and this is good because we can undo some of the arctan function by taking the tan of both sides. We can try to prove the tan of the left hand side is equal to the tan of the right hand side. So we could attempt to prove this is true. Okay, for the left hand side, since we have pi over 4 plus arctan of 1 over 239, we can use the angle addition formula for tan. So we have tan of pi over 4 plus tan of arctan of 1 over 239 divided by 1 minus tan pi over 4 and tan of arctan of 1 over 239. The tan pi over 4 is equal to 1. And since we're taking tan and arctan of 1 over 239, the operations will cancel out to just give 1 over 239. And we have 1 minus the tan pi over 4 is 1. And the tan of the arctan just gives us 1 over 239. This is equal to, if we multiply numerator and denominator by 239, we have 239 plus 1 divided by 239 minus 1, which is 240 over 238, which is 120 over 119. Okay, now let's look at the right hand side. The tan of 4 arctan 1 over 5. So so we can actually use the double angle formula for tan twice. So we can write tan of 2 times x in terms of tan x and tan 4x in terms of tan 2x, using the double angle formula for any x. So what we can do is first find tan of 2 arctan 1 over 5. Using the double angle formula, we have 2 tan of arctan 1 over 5 minus divided by 1 minus tan of arctan 1 over 5 all squared. Since tan and arctan cancel out, so we have 2 over 5 divided by 1 minus, and tan and arctan cancel out again, so we have 1 over 5 squared. Multiply numerator and denominator by 25 to get a nice fraction, which is going to be 10 over 25 minus 1, which is 10 over 24, or 5 over 12. We have 5 over 12. Okay, now to find tan of 4 arctan 1 over 5, we can use a double angle formula again, where we substitute 2 arctan 1 over 5 divided by 1 minus tan of 2 arctan 1 over 5 and take the square of it. And now we have 2 times, so we have 5 over 12 here from earlier, divided by 1 minus, so we have 5 over 12 again, and squared. Now multiply both sides by 12 squared, which is 144, or multiply numerator and denominator to get 10 times 12 divided by 12 squared minus 5 squared, which is 120 divided by 144 minus 25, which is 120 over 119. And in fact, it means the tan of the left hand side and the tan of the right hand side both give us 120 over 119. So it follows we have the thing we wanted to prove is true. So we have tan of pi over 4 plus arctan 1 over 239 is equal to tan of 4 arctan 1 over 5. Okay, since the tans are equal, in order to prove that the individual expressions inside the tans are equal, we want to make sure both these values are between 0 and pi. And this is because tan of x, so tan of x is a one-to-one function on 0 pi and excluding pi over 2. So tan x is a one-to-one function on 0 pi because it goes from 0 up to infinity, from 0 to pi over 2, and from negative infinity back up to 0 from pi over 2 to pi. That's why it's one-to-one in that interval. So what we can do is, if you look at pi over 4 plus arctan 1 over 239, this is at least 0. This is greater than 0 because since arctan 1 over 239 is positive, it'll be greater than 0. This is less than pi over 4 plus arctan of 1 because 1 over 239 is less than 1. So this is equal to pi over 4 plus pi over 4. This is equal to pi over 2, which means this expression is between 0 and pi over 2. Okay, and now we have the 4 arctan 1 over 5. Okay, so 0 is clearly less than 4 arctan 1 over 5. This is less than 4 arctan. We put 1 over square root of 3 here. And this is a well-known value which is equal to pi over 6, or 2 pi over 3 here. 4 arctan 1 over 5 is less than 2 pi over 3, so that means both of these values are between 0 and pi, and it follows that since tan is a one-to-one function on 0 pi, and since both of these numbers are between 0 and pi, it follows the things inside the tan function must both be equal. So we will get pi over 4 plus arctan 1 over 239 is equal to 4 arctan 1 over 5. And from rearranging, we get pi over 4 is 4 arctan 1 over 5 minus arctan 1 over 239. Okay, and this concludes our proof of this trigonometric identity involving pi and some interesting numbers. So we have a 5 popping up and this larger number 239 popping up. That was quite a nice problem. So I hope you enjoyed this video. Thanks for watching, and I'll see you next time.